So now let's look at some practice problems for combinations and NCR. As with all of these, I will put in links to the following problems. I'll present the problem, give the answer. If you don't need the solution worked out, move on to the next problem. If you do want to see the solution worked out, I'll give a full explanation of why the solution is what it is. So, example 1, in a business meeting with 14 executives, if each executive shakes the hand of every other executive exactly once, then how many total handshakes occur? Take a few minutes and pause it, solve this problem. The answer is 91 handshakes, and here's why. So if we have 14 people, one handshake consists of 2 people shaking hands together. So basically we're saying, if I want to have every possible handshake occur of my 14 people, I want to see how many ways I can choose groups of 2, 14C2. 14C2 is going to be 14 factorial over 14 minus 2 factorial, 2 factorial. Feel free to jump to 12 factorial there if you've gotten used to this. So 14 factorial over 12 factorial, 2 factorial. And in here, 14, these are what I'm going to cancel. 14 is 2 bigger than 12, which means I have 14 times 13. I don't need to write it, but I will for this example. There will be a 12 factorial left over there, a 12 factorial left over here that will end up canceling. And then I still have 2 times 1, that 2 factorial. And to finish it off, I can reduce down some stuff. So instead of trying to multiply 14 by 13, then divide by 2, I would reduce this down first. So 14 divided by 2 times 1 is going to give me 7. 7 times 13 gives me 91. Problem 2. You are a terrible cook with 7 ingredients at your disposal. If you consider a dish unique based solely on which ingredients are in it, and not on how it's prepared or the amount of each ingredient in it, how many different dishes can you create with exactly 4 ingredients? How many different dishes can you create with at most 4 ingredients? And how many different dishes can you create using any number of these ingredients? Pause the video, solve these problems, and here are the solutions. 35 for 4 ingredients, 99 for at most 4 ingredients, and 128 using any number. So here's the way this works. If I want to figure out how many dishes I can create with exactly 4 ingredients, out of the 7 ingredients, all I need to do is choose 4 of them to be in the dish. 7C4, 7 factorial over 7 minus 4 factorial, 4 factorial, which is 7 factorial over 3 factorial, 4 factorial. In this case, this number is bigger, so I'm going to use that to cancel out as much as possible. 7 is 3 bigger than 4, so I'm going to have 7 times 6 times 5. I have this times 4 factorial left over, which you do not need to write, because it's just going to cancel out with the 4 factorial at the bottom. And then 3 factorial is 6. The 6's are going to cancel. 7 times 5 is 35. How many dishes can I create with at most 4 ingredients? Well, that means I can have 4 ingredients, 3 ingredients, 2 ingredients, 1 ingredient, or if I'm a really bad cook and I'm going to consider this mathematically, I could have the dish that has nothing in it. So basically I just need to figure out 7 choose 0, 7 choose 1, 7 choose 2, 7 choose 3, and 7 choose 4. Now, I'm either doing 0 ingredients or 1 ingredient or 2 ingredients. I'm not going to do 1 and 2 ingredients at the same time, so I'm not multiplying. I am adding these up. I guess I can show the start off. So this is going to be 7 factorial over 7 minus 0 is 7 factorial 0 factorial. This is going to be 7 factorial over 6 factorial 1 factorial. This is going to be 7 factorial over 5 factorial 2 factorial. This is going to be 7 factorial over 4 factorial 3 factorial. And finally, this is going to be 7 factorial over 3 factorial 4 factorial. Working those out, this is going to be 1. Whenever you have something choose 0, there's only one way to do it. You haven't chosen anything. 7 choose 1 is going to be 7. Whenever you're choosing one thing out of a group of n elements, the answer is going to be n. You can choose any one of those n elements. This right here we actually did on a previous slide back, I think last video. It'll end up being 21. When I cancel out the 5, I have 7 times 6 divided by 2 times 1, works out. This right here, I'm going to cancel out the 4 factorial, 7 times 6 times 5, divided by 3 factorial is what we did sort of up here, and I'll get 35. And these two will be the same. We saw that last video where if these two numbers add up to the n, how many this is out of, then 7 choose 3 is the same as 7 choose 4. 7 choose 3 is the way to choose 3 to be into the set, which is the same as choosing 4 to be out of the set. So that will also be 35 without any work needed. And 35 plus 35 is 70, plus 21 is 91, plus 7 is 98, plus 1 is 99. And then finally, now I could continue this process and do 7 choose 0 plus 7 choose 1 all the way up to 7 choose 7. But there's a smarter way. If there are 7 ingredients, I can either have an ingredient in a dish or not in a dish. So I can either sort of turn the ingredients on and off. So for each ingredient, there are 2 possible states for it to be in. Either it's in or not in. So it's the same as doing 2 times 2 times 2 times 2 times 2 times 2 times 2, which is 2 to the 7th. This number does include where all the ingredients are in the sort of off state, where there's nothing in it. So it includes the empty dish, and it includes where all of these are in the on state, where you have whatever the mess, all that is in here. 2 to the 7th is, of course, 128. Example 3. You are coloring a coloring book page with 12 regions. If you have 3 colors, in how many ways can you color the page so that 2 regions are colored one color, 4 regions are colored a second color, and 6 regions are colored the third color? Pause the video, take a few minutes to solve this. And the answer should be 83,160. So here's the thing. In this, each of the colors is distinct. There's an order. There's a first color, a second color, and a third color. So I'm going to start off by choosing colors. And that's going to be either 3p3 or just 3 factorial. That's the way to choose the colors. Which color is first, which color is second, which color is third. And once I choose the colors, once I permute the colors, now I need to start filling in things. So I start off with 12 regions. And from those 12 regions, I want to choose 2 of them to be color 1. So 12 choose 2. Once I've colored 2 of them color 1, and actually let me change the colors so I can talk about this better. So 12 choose 2. Once I've colored 2 of those regions color 1, there are now 10 regions left over. And I want to choose 4 of those regions to be colored color 2. Now this is actually good enough to satisfy it because all of the rest of the regions will be colored color 3, but I'll put it in here just to sort of complete the idea. There are now 6 regions left over, and I'm coloring in 6 of them color 3, and this is going to give me my answer. Again, this was to assign color 1 through 3. This is where I color the first color. This is where I color the second color. And this is where I color the third color. And when I multiply this all the way through, I will get 83,160. Example 4. You are running a contest with 100 people. From these 100 people, 3 will be chosen as winners. How many different possible groups of 3 could you get? Pause the video, solve the problem. You can get 161,700. And the idea is this. In this problem, there is no difference between the first, second, and third winner. They're all just winners. So this is a combination, not a permutation. I just do 100C3. Either put in the calculator. I guess I'll show another calculator. I haven't shown one in this video yet, so I just do 100 math NCR3, and that'll work. Or I could do 100 factorial over 100 minus 3, which is 97 factorial, times 3 factorial. And that's the bigger number. I'll cancel out what we have. We'll be left with 100 times 99 times 98 times this 97 factorial, which is going to very quickly cancel out with this 97 factorial. Times 3 factorial. And I can just work this out. So let me change this 3 factorial, expand out to 3 times 2 times 1. And I can see, let's see, what's probably the smartest way to do this? I guess, ooh, did I say 3 times 2 times 2? There. So I can do the 100 and the 2 and get 50. I can do the 99 and the 3 and get 33. And then just bring down the 98. That's going to deal with everything. When I multiply that through, I mean, I could do it by hand. So 50 times 33 is going to give me, let's see, 1, 5. So I think that's going to give me 1650. And then I can multiply that by 98. At the end of all of it, I will get 161,700. All right. Example 5. A game of tic-tac-toe begins with an X followed by an O, and continue until someone wins or there are no squares remaining. Assuming that 2 players continue to place X's and O's until all 9 spots are filled, how many different completed boards are there? Pause the video, solve the problem. All right, there are 126 boards. So the reason is, in a tic-tac-toe board, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. And if I start off with an X and then go to an O, so X, O, X, O, X, O, X, O, X, I will end up, to fill up 9 spots, I will have 5 X's and 4 O's. So basically, all I need to do is consider 9C5. I need to choose 5 of these squares to be X's. 9 factorial over 9 minus 5 is 4 factorial times 5 factorial. These are the bigger one. Oh, sorry, this is the bigger denominator, so I'm going to cancel out with that. So 9 times 8 times 7 times 6 times 5 factorial, which will cancel out with this 5 factorial. 4 factorial is going to give you 4, 3, 2, 1. Ooh, slow down. And there are a few ways you can do this. I would usually, let me think. I'd probably try to get rid of the bigger numbers completely first. So if I can completely get rid of a number, that's good. So this 4 and this 2, 4 times 2 is 8. So that will cancel out the 8 up there. And then the 3 and the 6. 6 divided by 3 is 2. And now I'm just going to do 9 times 2 is 18. Times 7 will give me 126. Okay, last example. How many ways are there to permute the letters in alabaster so that there are no adjacent A's? Pause the video, try to solve this. Okay, here's the idea here. There are 25,200 ways, and this is what's happening. The first thing I'm going to do is I'm going to look at this and just deal with the non-A's. So there are 1, 2, 3, 4, 5, 6 non-A letters, and there are no repeats. There's an L, a B, S, T, E, R, so I get 6 factorial ways to deal with that. After I have that, let me put this up here. So what's going to happen is this. That's what places these letters, the non-A's. If I want to make sure that the A's are not adjacent, I just need to make sure that I fill these in between other letters. So basically I can put an A here, I can put an A here, I can put an A here, 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 or here. I can put this A in any one of these 7 spots. And I need 3 A's, so I'll end up with 7 choose 3. 6 factorial is 720. 7 choose 3 is 7 factorial over 4 factorial, 3 factorial. That's going to reduce down for me. So 7 times 6 times 5. I don't need to write it, but I'm going to. 4 factorial, 4 factorial. Because this 4 factorial, actually, the 4 factorials are going to cancel. I still have the 720 from 6 factorial. And now I can also see that 6 down here, 6 up here, they'll cancel. 7 times 5 is 35. So 720 times 35. And that's going to give me 25,200. Okay, comment with questions if you have them. I will put up an additional video here where I deal with all of the probabilities of the five card poker hands.